It's a hobby for those persistent enough to overcome great frustration. It's a hobby allowing us to turn our backyard into a window to the universe. It's a hobby that reminds us how small we actually are and continues to amaze the world every day. I can show you how to photograph objects so beautiful they could be called gems of the night sky. Join me to photograph one of these gems, the Cocoon Nebula. The good summer weather is finally here. The day is not too hot and the night's beautiful clear. If you are familiar with some astronomical objects, you will know why I need the big refractor tonight. The Cocoon Nebula is basically a small ball, somewhere in the constellation Cygnus. It's a small emission nebula glowing in a pink, red, violet tint. There is no moon tonight, that's why I will take the light pollution filter and not the narrowband filter. And it's one of those nights you look at the forecast and know it's gonna be clear 100% the whole night. These are the nights where you are so excited for that you want to plan everything so that it won't fail. Let's wait until sunset. Alright, I can see Polaris, the night can start. Or at least I will be able to see it if I get this light out of my face. I've entered a custom object, the Cocoon Nebula, with correct orientation and positioning in the catalog of APT. And if I get the plate solving running tonight, it had a few bumps last time. This will be great. I just remembered I need to swap the filter. I still have the Nebula booster filter, which I don't want right now. I want the light pollution filter, broadband, beautiful, true color. I need to do that. I need to set up the guiding and everything, the tracking, and I need to clean the telescope from dust. So let's do that. And that's where the camera ran out of battery. Hello everybody, welcome to the editing part of this video. There are a few things I wanted to talk about for the Cocoon Nebula. Here you can see the image of the Cocoon Nebula as it comes out of APP, my stacking software, and you can see anything, maybe some stars. It's still linear, let's take a look. So this is the image how it came out of APP. So there was the light pollution removal, of course. The background looks fairly smooth, it looks way too red. It's noisy, as you can see. There are way too many stars, and the nebula is maybe orange. I don't know how to describe that color. For many people, most of these editing steps, especially in PixInsight, are still unknown. And if I now show you the final image, this looks way different. This final image is okay, I'd say, in my opinion. There could be done many more things, but I don't have the skill to perform more. But let's talk about the steps I took. You can see every time I hit the red mouse button it says what I'm doing. The multi-scale linear transform is basically the noise reduction. Let's zoom in. So this is the first part of noise reduction. It softens the stars a tiny bit, but only if you zoom in a lot. So you don't see much if you zoom out. Nothing at all. The next part is histogram transformation, and I stretched the image. The stretching in PixInsight is not that hard. I did it with the basic screen transfer function and histogram transformation. If you want more in-depth tutorials about PixInsight, I have an entire series about that on the channel. Just some main steps what I did in this image. Local histogram equalization, that's where the first mask came in. You can see I have a lot of masks here. This is an image clone. This is a star mask for the deconvolution. I tried deconvoluting this image, I still hate this process, and so I skipped it after it didn't work for 2 hours. I used this mask to mask out the nebula and then perform the local histogram equalization to get the contrast in there busted. This looks good. And just one tip with the masks, maybe I can still help some people. Making the mask only in the nebula like this doesn't work, the stars are in there. Smoothing it out doesn't work either. You can still see there's a lot of stuff around the nebula we don't want in our mask. But what I did here, you can apply a curves transformation to this mask. So I'm gonna pull down this part and leave this one untouched. And that's how this mask was created. Alright, the next step is the morphological transformation, also known as star reduction. Many people do it at the end. In this image, for example, you can see there are so many stars, it's so annoying. So many stars that the object doesn't come through at all. In the nebula and the dark nebula, you can see the dust lane going from here to the red side. It doesn't really show, there are so many stars blocking it. And that's why the first star reduction you can see makes it green, actually, this image. And of course this was also done with the morphological tool and a star mask. Then we have the ACDNR, which is a noise reduction tool, this one. And this noise reduction tool is best used for stretched images, so just like this. Let's see. Yes. If I press Ctrl Y and Z here all the time, you can see. Also the color was noised out, cancelled out, let's say, the color noise. You can apply to the chromians, and if you increase the bright side edge protection, it actually gets rid of some color. The curves transformation to make the nebula pop a tiny bit more, and then the SCNR, just to get the green out of the image. It makes everything more bluish in the background. And you don't need a mask for this most of the time. Curves transformation for the nebula, again ACDNR to get more noise out of the way, and that's the point where the stars actually suffer a tiny bit. Another curves transformation, background a tiny bit darker, preserving the nebula. Add many more of those. Let's take this example. You can see the bright spots and the darker spots are of course stars, but you can see that the stars in this edge over here are not that bright, or over here as in the center of the image over here. So applying the star reduction will not affect the stars in the top left that much. And that's why you can see, zooming out, tiny stars over here and big stars over here, not affected. I don't know why these masks are created like that, but I found a tiny way around that by going onto this mask. Where is it? With the curves transformation again, so pulling up the dark spots and getting down these ones. Maybe not that much. So now if you... Alright, this doesn't look right, but if you work on this a tiny bit, it will work wonders. And the next steps are just the morphological transformation with shifting masks. Always try to get a new mask for each iteration of the transformation. Again, in SCNR it didn't seem to do much. And you can see at this point the small stars are just not there, or they merged into weird shapes. I don't know way around that, and that's why I don't like these targets in the plane of the Milky Way. So many stars, you have to reduce them so much that they will look awful.